Okay, this problem is the last of the problems from this particular exam. And this one is a collection over water where you have to subtract out the wet air, because remember, pressure total is equal to the pressure of whatever gas you're looking for, in this case oxygen, plus the water vapor. Okay, so we look at this one. Oh, well, the first question on this one, it says balance the equation. So when we look at it, I've got 2 silvers, so I'd need 2 silvers over here. And then I go back and I have 1 oxygen on the reactant side, 1 oxygen on the product side. So you're like, okay, let's go backwards. Let's double that. It gives us a 4 there and a 1 on the oxygen. So there's our balanced equation. So we're told that silver 1 oxide decomposes and produces that many milliliters of oxygen gas. The question is how many grams of silver oxide decomposed. So what we need to do is first we need to find the moles of oxygen gas generated. Well, if we're looking for a gas, then that means we're going to use PV equals nRT. On most of these collection over waters, you're going to do a stoichiometry and a gas law. The question only becomes, do you do the gas law first or the stoichiometry first? So in this one, we're going to do the gas law. Okay, so volume we know is 0.1658 liters. We know that temperature is 49.34 degrees C, which means it's 322.49 K. And our pressure is 1.060 atmospheres. Now, here's my problem. Is that I know that this is my pressure total. So I need the pressure of just the oxygen. And I was told the vapor pressure of water at that temperature this is my vapor pressure of water. It's in torr. So either my atmosphere has to go to torr or I have to convert that to atmospheres and subtract. It doesn't matter. It's actually a simpler process if you convert the torr of the vapor pressure to atmospheres, but I don't know why I don't do that. So I'm going to go the long way. So I know that 1 atmosphere is 760 torr. So that means that I get 805.6 torr is my total pressure. So that's P total minus my 89.36 torr, which remember is my water vapor. So I end up with my new pressure, which is 716.24 torr, which I then have to convert back. As I said, this is easier to do it the other way. I just don't know why I don't do it that way. And so you get 0.94242105 atmospheres. Okay, so now, again, if we're doing PV equals nRT, then N is equal to PV over RT, which means its pressure, which is 0.94242105 atmospheres, times volume, which is 0.1658 liters, divided by gas constant, which is 0.08206 liter atmospheres per mole K, times temperature, which is, there it is, 322.49 K. So when we do the math, we end up with 0.0059044 0.8115 moles. Now, I was told to report the answer in 4 significant figures, so let's keep 4 significant figures. That means we're 5904 moles of oxygen in 4 significant figures. So, we've got our moles of oxygen, but that's not what we want. We want to know how many grams of silver oxide were decomposed. So, we're going to start with our moles of oxygen, and we're going to leave it in moles because we're going through the equation, and we know that for every 1 mole of oxygen, we had 2 moles of silver oxide. And in order to do that, we had 1 mole of silver oxide is 231.7358 grams of silver oxide, and that's 273.6336 grams of silver oxide. Which, again, if we're using 4 significant figures, which is what we're asked to report it in, we get 2.736 grams of silver oxide. This is how you do a collection over water. And this pretty much takes care of the big problems in the test over the thermochemistry chapter and the gas law chapter.